Hey guys, Ajax here, and I am sorry it has taken so long to get back to this series. Moved across the country. I moved actually like 6 or 7 times in the last 3 years, and been pretty crazy. But that's not really any excuse. I've just not really known where to go with the series. So that being said, we're gonna try something a little different than we did last time. Last time we started with some really simple games and then started kind of ramping up into more complex ideas. And the last episode was sort of trying to break ground on a game engine, which really wasn't like the right way to take the series, I don't think. And the other thing is, I was working with a very simple tool that I knew pretty well. And I don't know how much further I could take that in a simple format where we do have, an hour or two video. So instead, what we're going to do is, and I'm curious what you guys think of this idea. If you like it, we'll keep doing it, hopefully. If you don't like it, we can think about, what changes to make. I'm going to go through some different game tools, some game engines, some rendering engines, game libraries, 2D, 3D, and we're going to try simple games still. Maybe redo some games like we're going to do today, and try them in different environments that I don't necessarily know as well, but we can learn together and kind of get a feel for how different they are and what we really like and don't like about something, and kind of have some comparison between them. This is hopefully going to be an incentive for me to keep this going because I'm really interested in getting my own games off the ground again. It's been a long time since I've been doing a lot of game development. And I am trying to find the tool that I want to use myself. So hopefully that will be an incentive for me to record these videos as I'm learning the tools. So today we're going to start with Unity. Unity is arguably the most or one of the most popular game engines on the market right now. I'd call it more of a game development environment than just an engine, and we'll talk about that in a bit. But it provides you with basically everything you need to get going with the game very quickly. I played around with Unity now for, I think it was 2 or 3 days ago. I installed it. Done a couple different versions of Pong just to make sure I don't get in here and have no clue what I'm doing. and had some help from some people watching the video, the stream, as I was working on that. And yeah, I think I got a decent enough feel for it that we can do this. So just so you know, disclaimer. Like I said before, this is not something that I know or am an expert or let alone even proficient with. I don't know Unity very well. Also, the thing with Unity is it only really allows C# as your scripting language. There's plugins for Python, but basically you end up writing C# with strings that have Python in them, and it doesn't look good. So we're going to be using C# here. And I'm curious if people would prefer if I stick with Python engines or if they don't mind branching out into other languages. And C# is not a language that I am as familiar with in any way, shape, or form. I've only really used it in 1 or 2 projects, and they weren't ones that I wrote. They were ones that I ended up coming in to maintain. So with all of that aside, let's get in to making Pong in 3D with Unity. So, the first thing that we're going to do is I'm going to hide my ugly face. That way you can actually see everything that I'm doing this time. And we're going to start up Unity. So this is 2017.4.2 F2 version. I do know they came out with like a 2018 one, but I am using the free version, and this is what I got. So to install Unity, you're going to go to the Unity website. You're going to tell them you're using it for a personal project. You're going to download it. You're going to have to repeat that like 2 or 3 times. And basically, it's free to use. You don't get all of the high-end features and support, but it works pretty fine. Once you have Unity, I strongly recommend going to Learn and going through these 4 tutorials. You just start them. What they do is it opens up a project window, and it has, prompts in the top left that tell you what you need to do. It's not really that helpful in the long run, but it'll get you up to speed and familiar enough with the environment that you feel comfortable diving in. So what we're going to do is we're going to create a new project, and we're going to put this inside of our Let's Make a Game directory here in our episode 6. And this is going to be Pong3d. We're going to create the project. Now, one thing you'll notice as we're working with Unity is the ramp up time, especially in these simple games, is going to be very quick. So when we were doing the Pygame version, we had to create variables to handle all the different things and, create our rectangles and our circles and our walls and all of that kind of stuff. So this is Unity. And the difference with Unity is, like I was saying, more of a game development environment. It has a very powerful engine, but it's so much more than that. I personally don't care for that very much. I prefer the more sort of controlled way that we do with Python and Pygame, where you have a script that calls the engine and tells it what to do. Whereas in Unity, what we're gonna do is we're going to create objects in the world, and the engine, basically the environment, there is an environment that we're putting stuff into. And we're going to create some objects, and then we're going to assign scripts to those objects that control what they do. So instead of having a script that's telling the engine what to do, we have an engine that's calling our scripts to kind of ask, what do you want me to do in this situation? Okay? But it does have the advantage of letting you get going very quickly. So the first thing we're going to do, this is our hierarchy of objects, our scene graph, if you will. We're going to create a 3D object. We're going to create a cube, and we're going to call this our player paddle. So our player paddle doesn't look much like a paddle right now, but we're going to come over here, we're going to click on Inspector, and here we can see everything about our paddle. So we're going to start everything at 0, 0, 0 to begin, right? So it's at the center of the play area. Now we're going to move the paddles in the along the x coordinate. So that means we're going to scale them along the x coordinate to be wider. So let's say we want to have a game area of, say, 10 by 20, right? So we want to make our x, say, 2.5. So it's like a quarter of our game area. Or, let me see. So this is x. We're moving along x. So we actually want to scale our z. I'm sorry. Wait. No, I don't. We're going to be moving along. Okay. Pick an axis, right? So right here, I'm actually have to just pick which one. We're going to take the one that's already defaulted on. I think I want this to go this way, and we'll have the other one over here. So we're gonna scale it along z, and we'll handle it along the z axis. 2.5. So that means the x axis doesn't need to be as thick, right? Because it's just a paddle. So we'll make it 0.5. And we'll make the y 0.5 as well, so it's a little bit thinner. Now we're going to move this then along the x-axis back 9. Oops. Back 9. And we'll zoom this out so we can see. And what we're going to do is we're going to duplicate this, and we're going to rename this to the AI paddle. Now you can use this to create a project, or create a prefab, it's called, and then it basically creates like this baked object that you can just insert into your scene however many times you want. We're not going to do that right now, just because when I was doing it, it felt like it made everything more complex needlessly, but again, that's probably just my misunderstanding. But we're going to keep it simple for this. So we're going to create an empty object, and we're going to call it our walls, well, our bounds. So inside our bounds, we're going to create a floor. And so the floor is this cube. So the floor is going to go under where the game area is. So we're going to go negative position -1. I think we're actually going to end up needing to go 0.5. Yeah, everything is 1 by 1, but it's centered at 0. So it's like plus 0.5 and negative 0.5. So to really actually touch everything, we're going to do negative 0.5. So our scale then along the x is going to be, this is our x, so that's going to be 20, right? And our scale along the z is going to be 10. That's kind of our game area. Our Y can be like 0.1, so it's really not that thick. And that puts us like right at our position. So that means our little paddles are floating a little bit. So we're going to create our walls now. Cube. So this cube is going to be, rename wall. And this wall is going to be one of our lengthwise walls. So it is going to be 20 along the Y. And we're going to make this that, and we're going to make our Z 0.1. We don't want it to be too thick because that'll look weird. And then we're going to move it along the Z axis, -10. -5, that's right, because again, we're centered at 0. And there it is. And so we're going to create another one here. And this one's actually just going to be at +5. And our scale here should be 0.1. All right. And then we'll create a new wall here. So we're going to create a new 3D object. This is going to be this one. So this one is going to be along the x-axis, or along the z-axis, 10. And so this is going to be 0.1. And then we'll move this along the x-axis to -10. And we will rename wall 2. And we will duplicate. And we will put this at +10. We now have our walls. So if we look at that, looks pretty decent. And then we need to add our ball. So we'll just add a sphere in the middle and put it at 0, 0, 0. And we'll leave it at scale 1 of 1 because I think that looks decent. Now, let's color things, because right now it looks so weird that it's going to be like, what are we doing? And the camera angle is also messed up. Like if we look down here in the game, this is what we'll actually see from the game. So you can see our camera's over here. So we're kind of just like looking at the game like a little kid looking over the top of the game board. It's not really what we want. So what we're going to actually do is we're going to take the main camera and we want to put it behind where the AI paddle is. So the AI paddle, or for the player paddle, I mean. So the player paddle is at 009. So if we put this at 009 as well, and then we can rotate it along our Y 180 degrees to turn it around. And not 180, we need 90. 270. It's looking the wrong way. Okay, so now it's looking the correct way. So what we can do is we can move it behind the paddle a little bit, so we're not just looking at the ball and hiding everything behind it. So let's move it back. Let's say put it at 12, and then we'll move it up in the Y, say 3, and then we're going to rotate it along the Z axis. Let's say 45 degrees. That's not the axis I want. Oh, it's because we rotated on our Y. 45 on our X. And that's not really right. So let's do a little bit less harsh. Maybe 30-degree angle? Well, that looks like it's decent. I mean, let's move it back just a little bit because I want to make sure we see the whole board. Sure, we can do that. That's not too bad. So we now have our camera pointed in a way that we can actually see what things are doing. Let's create some materials. So we're going to create some materials to make things look cool. We're going to make a floor material. So our floor material, let's make the floor black. And we will assign this to the floor. Now our floor now has this really shiny kind of metallic matte look, which is kind of cool. Now we're going to create a new material, and we're going to make this for our walls. So for the walls, let's give them something to kind of pop against the black, and yellow pops against black pretty well. Let's kind of try and pick like this goldish yellow, and we'll apply it to each of these walls here. And there we go. That looks pretty good, actually. A little bit greener than I meant, but we can play with that later. We'll make the ball, say, what color do we want for the ball? Maybe we'll make the ball like keep it kind of, like just let it be kind of this grayish color. And then we can actually make it emit so that it's like glowing, I believe. You know what? We'll leave emission alone because that doesn't seem to be doing much. I got it to work before, but it was a pain in the butt to get it to work, so we'll just leave that for now. Oh. Well, the reason we couldn't see it is I haven't actually assigned this to the ball yet, so if we change this now to emit, there we go. So it just makes it like, oops. Yeah, we'll just let it be this like metallic looking little ball, which is kind of cool looking. If we were to continue this, I'd probably want to bring in some sort of like map to make it look a little bit like it's, you know, a little bit like dinged up metal. But for now, we're okay. We'll make the player paddle blue, I guess, and kind of more of a light-ish blue that doesn't look too weird, I think, is what we want. Yeah, that's fine. And then we'll make the AI paddle red. And we'll just go, oh, there. All right, so now we have our paddle, their paddle, everything's colored. So that's a good start, right? So we're gonna save this quick. So inside of here, it basically saves it inside your assets. I just keep naming it project.unity. Whatever you want to name it is probably fine. So we have the light on the left side looking at everything. I kind of prefer it being on the right side. So let's change that. So the light actually is a physical object in the world as well. You can position it wherever you want. So we're going to, hold on. Oops. Let's see. So our light actually is at 030, pointing in a different direction. So let's actually change this here. So from the player's perspective, right? All right, we want the light to be over here. So let's put it at, I like it being up at 3, but let's put it along the Z-axis 10, so it's off screen. And we're going to actually not rotate it along its Y. We're going to rotate it -120 degrees, not quite enough. 160 degrees. Ooh, that's maybe too much, right? So 120 is here, so maybe 140. There we go. And I think it looks cooler if it's pointing away slightly, so we will rotate it along its Y a little bit here. But let's rotate it like 30 degrees along its Y. Maybe 45 degrees? That's a little too much. Maybe we need to change it now to be 160. Now we're getting too much. 145? That's pretty good. Maybe make this just like 40 so it's not quite. There we go. That looks, you can tell it's 3D now. So I think that looks fine to me. So we'll save it again. So now is the fun part. Let's get it so the ball is moving, and then we'll move on from there. So the ball, so we're going to create a, well, first we're going to create a rigid body. Sorry, no, we are not. We're going to create a physics material first. So this is the bouncy ball. So we're going to use the built-in physics in Unity instead of just like manually setting which direction it's going like we did in the other Pong one, to kind of show you a little bit of how you can take advantage of that. So because we're using a physics library, everything has some friction and it slows down. But if we set bounciness 1 and we make sure that the minimum friction is applied and the maximum bounce is applied, it's not never going to get slowed down from friction, and it's going to always keep the same speed when it bounces for the most part. There is a weird case I've seen sometimes when it gets like caught behind a paddle and keeps bouncing, but that should really end the game, right? So probably not that big of a deal. So we're going to apply this to our ball. I'm going to move the ball up here actually to keep it organized. So the ball now in our inspector has this sphere collider, which has the bouncy ball material so that it can just keep bouncing. Now we will also add to this a rigid body. So under add component in our inspector, we're going to add physics and rigid body. So in our rigid body, we can actually constrain this. So we don't want it to move outside of the Y constraint. And actually the player paddle and the AI paddle will add rigid bodies to as well. So they will be able to collide with the walls and not go through them. But for now, we'll just do the ball. So we want the mass to be relatively low. I've seen this help a lot, and we're going to turn drag to 0. And we don't really want to use gravity. We could use gravity since we do have a floor, but it isn't going to help anything too much. And we're going to save. So now this isn't going to do anything because we have changed not enough to really do anything. But what we've set up is the ball can do things now. So what we're actually going to do is we're going to create a script. So a C# script. I don't really know why it's called C# script when they've removed the other types of scripts, but we'll be explicit. So this is going to be our ball script. So we create it and we double click on it. And this actually will open a separate window, which is a editor specifically for C# for Unity. I'm guessing it's used for other things as well, but it's like a specific version of it. So in here, it comes with a little bit of helper, so you don't have to worry about doing your imports. You don't have to worry about setting up the boilerplate class. You have these functions instead. So you have start and you have update. Now, first thing we need to do is we need to get our rigid body. So we are using C#, like I said. So in C#, you have to define what properties a object has in its template before you really assign them, or while you're assigning them. So in this case, when this is going to be initialized, the game object doesn't actually exist yet, so we can't actually just do game rigid body my rigid body equals get my rigid body. We have to just define it for now, and then in our start, which is once the game has started going, we have our rigid body. Okay, so what we're going to do is we are going to say that my rigid body equals get component. So this is getting our component, and we care about our rigid body. So we're getting the rigid body version of the get component function, or well, method, I guess. This is on us. So what this is going to do is the mono behavior from Unity gives you a game object. And the game object has a number of methods on it, like start and update, but one of them is get component. Get component has a version where it will return the rigid body, and that's what we are requesting. So we have our rigid body, and we need to set our initial direction. So one thing that we do want is we want to say float speed. So if we define a public float, this actually, if you debug it and it builds properly, which it has, you can come back to Unity and you can assign the ball script onto our ball. And when you go to edit the ball, you'll see the script here. And our speed public attribute is now here. And we can actually set the speed from over here. So we can tweak it here instead of having going back to the script. So we'll say that we want the speed to be 10. So we want to set our initial velocity. So this is going to do my dot velocity equals new vector 3 And we can multiply that by our speed, because our speed is a float. So a vector 3 has 3 components, the x, the y, and the z. Now a vector can be used to indicate position, or in this case, we're going to use the vector just as and relatively just for our direction, for our velocity. Duh. So what we're going to do is we're going to say we care about it moving in the x and the z, right? So 0, 1. Now, we can update this later to make it start in a random direction instead of always moving in that one, but for now, that's probably decent. We're also going to come in here, and one thing that I have noticed, which you maybe will be able to figure out, well, actually, no, we'll start it and we'll see what happens here. So we press play, it comes down here, and the ball is moving. Now, if you notice, because it's, no, it's actually not. Okay, so this is good. This actually doesn't have a problem I had in one of my earlier scripts. So the thing is, we're going to look at this, and I'm like, the ball seems a little bit big. So maybe we'll make the ball a little bit smaller. So let's say we want 0.5 and 0.5 and make a little pancake, 0.5. So I have a little bit of a smaller ball that is now floating, the same as everything else. And that looks a little more Pong-like. But it's just bouncing all over the place, doing its thing. And there we go. So the ball doesn't really need to do a whole lot else at this point. But now we can handle other state. So now we can assign it. Let's make it so that the player can move, right? So we're going to add a script, a new script, right? So this is what I was saying, is when you create a script, you're assigning it to objects to handle their behavior more than anything else. So this is going to be our player. And we'll make sure we assign that to the player like immediately so it does something here. And we'll edit our player script. Player script, we don't have a rigid body on our player. So let's make sure that we add one to our player. Now for us, we are going to freeze this, and we want to freeze our rotation. That way, if we move the script, it doesn't like hit in and then try and like rotate and stuff. And that's pretty fine. And we're going to come over here, and we're actually just going to, so there's an update that comes with it. We're actually going to do fixed update. So fixed update occurs at a different time versus update and is more appropriate for constant movement. If you just use update, what you'll see is when you hit the wall, it'll vibrate back and forth because it's trying to run the check so many times. We don't really want to do that, but we are going to move it. So we can take our transform. We have a transform object, which relates to our transform up here. So our transform.translate. So we are moving in the Z direction. So we are never moving in X or Y, but we are moving in Z. Now, how are we going to move this? Well, in Unity, one of the helpers that it gives you is it automatically assumes WASD can be used for movement. So we can actually just get the axis. So we can call input.getAxis. And we care about the horizontal axis because we're moving left to right. And we can multiply that by time.fixed delta time because we're in the fixed update. And we can multiply that by our speed. So let's make sure we expose this. So public float speed times speed. Okay, and we run this, and we have an issue. Input does not contain get. I spelled axis wrong. It's not axes, it's axis. And that compiled fine. So now we don't have any speed on our player's script right now. So let's try setting our speed to the same thing that we set for the ball and see what happens. So if we put this here and we move, oh, we are really fast. So maybe that's too fast. That's just really easy. So we'll turn our speed down a little bit here to say 3. And we'll try again. So one thing that you can do actually, okay, so now we feel like really slow. So maybe, so we can actually edit this while we're in the play. Now anything you edit, with some exceptions, anything you edit while the game is running, there's blue up here, will be reset when you stop running. So for this sort of thing, you can use it for like testing, and now it's a different speed. This feels more appropriate. There we go. So we're good. So we'll end the play. We had to come back, so got set back to 3. We'll put it back to 5 because we want to keep that, and we're good to go. So the player's paddle now is handled. So that's really quick. We're at, what, 30 minutes in, mostly of me talking random nonsense. Actually, time it took to build this, very fast, right? So we're going to add another script. Let's get the AI so it does something. So we'll do our AI script. And we will assign that to our paddle, and we'll open it up. Now, we're going to do another. We want to make sure we can edit this outside. Now, for this one, it has to have a rigid body as well. So we're going to come back to our paddle. We're going to add our rigid body. So what rigid body does is it allows it basically to collide with the walls and stop. It is kind of a container or a constraint. It's a constraint. So we don't actually need to utilize the rigid body here either. But we do want to, every time we update, check where the ball is. So we have to get our ball. So game object ball. So ball equals game object dot find, and we named this, was it capital ball? It's capital. So our ball. So this will allow us to actually have a reference to the other game object. Now we want to say float ball pause equals ball dot transform dot position dot z, because we only care about its z position. So if ball pause dot if ball pause is less than our transform, so transform dot, wow, I didn't mean to have to complete that, transform dot position dot z. Then, so if it's to the left of us, then we're going to move ourselves. So we're going to say transform dot translate 0, 0, -1 times time dot fixed delta time times speed. Otherwise, we're gonna else if, whoops, we'll just do this. So float our pause hit caps equals transform dot position dot z. So one of the things that you'll notice in in C# is inside of a class instance, you don't have to, or our methods, you don't have to refer to like this or self or anything like that like you would from like Python or JavaScript. It just assumes that you're operating on itself. So this dot ball or self dot ball or self dot transform is kind of implied. If you have a locally defined variable though, then it still works because it knows that you just defined it. So else if ball pause greater than our pause, probably just do an else statement, just if it's not less than, it's greater than, because the likelihood that the individual little the percentage point is going to equal exactly is unlikely. Actually, you know what we could do is we could change this to int so that it would kind of move like in chunks, but yeah, this will be so transform dot translate 0 0 0 1 just time dot fixed delta time times speed, because we don't need 1 times. Okay. And let's oh wait, this should be a fixed update because we're updating Rigidbody. And let's make sure it runs. It does. So we can come here, we can look at our AI script now, and we'll set the speed to the same thing as the players, and let's see what happens. So it is now tracking very slowly, not fast enough. So maybe the AI paddle needs to be faster or the ball needs to be slower, one or the other. I don't really know which. So we can, let's see, how do we want to handle this? Well, you know what? We'll leave it for now because maybe the AI is just really easy to beat. So we have 2 paddles, we have a ball, we have an arena, the ball moves, we have the AI tracking the ball, and we have the player moving. That's pretty good work. Now, to kind of get feature complete here, we need to have an ending of some sort. So, now this is moving into something I haven't actually tried yet. So let's think of a different way to do this. Let's say, let's create a empty object outside of paddle that we'll call just the game. And we'll actually move everything inside of that. So these are all children of the game. So the game can now, we can add a script to the game that will control the state of the game. I think might be the best way to do it. So let's look at Unity's docs here and see if there's a way to handle this that is better. So let's say Unity global variables. This is a bit old. Oh. Okay, so what we can do is instead of doing that, so let's just move everything out and get rid of that game object. Let's just come over here and make a new script. So down here, we'll create a script, which will be our game state script. This is not assigned to anything, so we'll have to see if this works the way I'm hoping it does. And let's just say, okay, how is this doing it? Class manager is, oh, okay, so we can just make a singleton. Okay, so class game state is a singleton tone. Oops, where did everything go here? Singleton cast. Now, I need to check if this is actually casting. I don't think, hold on, let's see here. Let's make sure I'm getting the terminology correct here. So C# less than, and then symbols. No. Class names between less than. Yeah, here we go. Generic type parameters. Generics at a very high level allow you to design a class that is agnostic of the particular type of one or more of its parameters. So it's basically getting a version based. Yeah, so it's not really casting, but it's declaring the type. So we're making a singleton of type this. And then it just has properties, because it's not going to do this stuff. Okay, so public Boolean. Oh, it's just bool. Bool playing equals false. So we don't start out playing. And then public bool 1 equals false. Public bool, well, game over equals false. So you're either not, if it both are false, then you need to start the game. If playing is true and game over is false, then you are still playing. And if playing is false and game over is true, then game's over. So if game over is ever true, then we'll play the game over screen. Okay, cool. So we're going to say we want, actually, you know what? We'll make these private and we'll do getters and setters to make sure things stay in a proper state. And we're going to say, public void start game. I really wish you didn't do that. So playing equals true, game over equals false. And then public void end game. Bool 1. Bool 1 game equals false. So let's say 1 game equals 1, playing equals false, and game over equals true. And then we have public void reset. Hi, what's up? Reset. So reset. 1 game equals false, playing equals false, and game over equals false. Now we'll have to figure out so we could actually have this reset the ball too. So what we can say is the ball here would be public void roll ball, and then we'll do this here. So we don't actually want to roll on our own. We don't really need our update because we're not changing anything. Our player, we don't need the start because we're not changing anything. So, but we are going to need some reference to game state. So the game state needs to find the other objects to be able to initiate what they're doing. So it needs to know about the ball, right? So game object ball, and when we maybe let's make this a function. Game object get ball. Return game object find ball. So when we start the game, we're going to say get ball dot roll ball. Do we need to import something to use Singleton? The type of namespace Singleton could not be found. So let's see what we got here. Unity Singleton. Unity Singleton. Oh. Grab the Singleton script above and you simply use as such. Oh, okay. So we had to get this. Okay. So we'll grab this. What is this doing here? This is a... Do we need this? Let's just... So it's a mono behavior. So maybe we'll just make this a mono behavior. Name object ball equals get ball. Ball dot roll ball. It shouldn't need a first. No, the first object is the self. Okay, so we'll change this up. We'll let this just be a state handler, nothing else. Do we pull this in? Well, let's just see if we can reference this from the ball. So we need public void, not public void, void update. And in here we'll say if game state, so bool started equals false. If game state dot playing, then we will say, and not started. Then we'll say started equals true and roll ball. Can this build? Playing is inaccessible due to its protection level. Okay, so public bool playing return playing public bool is game over. Oops. Return game over. And then say public bool did win game. Turn one game. And then we have reset. Okay, so see if we can still access it if it's a mono behavior. Singleton. Because I want to add some events to the game state where it checks input. So don't care about this. So the ball, let's try now. Type game state already has definition for, okay, is playing. Okay, that is playing, boom, boom. And an object reference required for the non-static field method or property game state that is playing. So we can make this public static. Or is it static public, I think, maybe? And maybe we just make these public. I mean, I don't think that's the proper way to do it in C#, but so static, I think, makes it related to the state of the thing. Okay, there we go. So static makes it a property of the class rather than an instance property. And here we go. And okay, cool. So what we can do is now the ball will be able to check if it's playing and not started. And then void roll ball, void reset ball. My rb.velocity equals new vector 3 0 0 0, and my transform dot translate dot transform dot position equals new vector 3 0 0 0. Boom. That's not right. Oh, this, I'm kind of a dick. Let me make this bigger here. I'm sorry. I didn't even think about this. View, zoom in. How do you do Control++? Okay, cool. That on all of these. Okay, so I'll go through each of these again in case people haven't really been able to see what I was doing. So using system, this is all boilerplate. Rigid body, float speed started, roll ball, reset ball. This is our ball. And our player is even simpler right here. It just has a fixed update using speed to move it based on our input axis. The AI simply has a start where it finds what gets the ball, and then it checks its position versus the ball position, then tries to move. And then we have the game state that we're building, which has whether we are playing, the game is over, we won, the game is, we want to start the game, we're playing, blah, blah, etc., etc. No, not to reiterate what I've said before. And I am noticing that I'm not really, Yeah, whatever. If you can't tell, I am out of shape making videos, so my apologies. This is a little bit random at times. I think I was probably really random before anyway, and I'm just not remembering myself being this random. So, all right. So the ball now will check if the game is playing and we haven't started. Now, if started and not game state dot is playing, then we need to stop ourselves, and we say started equals false, and then we say reset ball. Now we're going to need to do this for everything, like the player and the AI are going to need to do it as well. Now we really only care about whether we're playing or not. Everything here just needs to know if it needs to start accepting input or stop accepting input. So let's come over here and we'll say if game state dot is playing, then we can move. Else transform dot position equals new vector 3 0 0 0. So we're just going to reset our position if we're not playing anymore. And we're going to come over to the AI. We're going to do the same thing. So if game state dot is playing, we're going to do all of this. Otherwise, we're going to reset our position. Transform dot position new vector 3. And we don't actually want 0 0 0 because that would be weird. Instead, what we're going to say is vector 3 starting position, and we'll set that from the start. So starting position equals transform dot position. Let's see if there's a clone, because that's going to get updated. So unity vector 3, and let's look at what we have on here. Can we just do new vector 3 from the old vector 3? Unity clone vector 3. Hello? Unity forms are being slow. This may not be something we need. Maybe it's possible that vector 3s, anytime anything modifies them, actually creates a new one. But we have stuff that's just changing the vector position, so I'm nervous about that. Wow, this is really slow right now. Here we go. Stretch. Oh, so we could just do transform dot. Oh, okay, cool. Can you set a transform position equals vector 3 networking? I don't think we actually need a vector 3. I mean, we could use that as our storage medium. Okay, no, we can set, okay, we should be able to set that. So we should be able to say, transform position. Yeah, position is a vector 3. Okay. Position 3 times 1. So, I mean, we're going to multiply it by 1, which basically just means we're going to just get a new one with the exact same situation. And then if we reset equals starting position times 1. Again, we just want to make sure it's not using the same starting position, or else after we finish the second game, it won't reset properly. Okay, so the player needs to do the same thing. Void start. Vector 3 starting position. And then starting position equals transform dot position times 1. This may be unnecessary, but I would rather be safe than sorry, and I don't want to spend all day just like testing each individual thing I run into that might be different than I'm expecting, or else we'll never finish the video because we're already at an hour. I want to start wrapping this up relatively soon here. So fixed update, if game state is playing transform translate transformed up position equals starting position times 1. Let's make sure everything builds. It looks good. So let's run the game. Make sure like the whole freaking kit and caboodle works, no errors. Okay, so the game is not running. Though interestingly, goodbye AI paddle. What just happened? Okay, let's look at the AI paddle here. So if we press play, it's moving. Oh, it uses gravity. And it's not colliding with the floor? Okay, cool. So the player paddle got locked. The AI paddle did not. So there we go. That should keep things from being weird. Cool. I don't know why that wasn't an issue before. I'm guessing because the ball was moving, so it was changing its position back to 0 constantly, so it didn't like move, but that's really weird. All right, now that we have our game state, now we need to do something with our game state. So let's create text, maybe? And interesting. We'll make the text controller based on the game state. So let's put this in position. Now I don't want this to be a 3D position. I really want this to be a event system. Oh, interesting. This must be added from something must have added that. Our canvas needs to be Well, let's add some text to it and see what happens. New text. It's not rendering. I don't know where it's supposed to render. Oh, it's right there. 000. It says new text. Color should be white. And it's not there. It's now centered. Okay, cool. So we have some text that's in the middle of the screen. So let's do the canvas. Let's actually add can we add a UI, like a background or something? A panel? That's maybe not what we wanted. So we could add buttons that we either see or do not see to start game. So let's add a button that's called the Start Game button. Start Game button. So we'll have our text element. We'll have the Start Game button. Start Game button has text on it, which is Start Game. And that's perfect. That's a button. When we play, we should see that we can like click it and shit and it just doesn't do anything. So that's good. And then we want to yeah, that's perfect. So the text is going to start out and say, welcome to Pong3d. Cool. And we'll enter. Oops, save that. So the problem is the text needs to be up a bit. So we're going to say negative. Oops, this is going to go up. That's right. Welcome to Pong3d. So let's make this bigger. Let's make this like 20 something. And width needs to be, interesting. Let's make our width 200. Welcome to Pong3d. Boom. Okay, cool. And then we can start game. And then what we can do is actually have other text that's at the same position that's going to be for other things. So this is going to be rename welcome text. And then we'll add, we'll duplicate this actually and say, that moves over here. This is going to be rename lost text. And then we'll have one more, which will be, come back, rename one text. Okay, cool. So lost is going to say, you lost, try again. And one is, congratulations, you won. Okay, cool. And so what we'll do is we'll say that this should, by default, not show. So how do we turn this on and off? Let's say, for now, we set this Y scale to 0. Okay, cool. Yeah, we'll just set the Y scale to 0 when we're not showing something. So, start game on click. So there's a button script. Really? How do I open this script? Edit script. How do I edit this here? On click. Oh, cool. Okay. Game state dot start game. Is that what we called it? Start game. And let's see what happens. Well, that's not doing anything. So, okay, well, let's look this up quick here. Unity button call function. Class calculate button serialized field private button my button. Select the button. There should be a button component in the inspector. Add a new plus symbol on the click list. Now you have to drag the game object with the attached script in the new entry. After that, you'll be able to select a function. Oh, okay, so instead, our start button, let's minus that. On click, games. Oops, start button. I want to drag game state. Game state. Okay, and then what is string name? Make sure the functions you wrote are declared to be public. I do that in shit. They are public. Oh, static public. No, it should be there. Maybe I have to rebuild. And then we come here and we say it's not showing up. Maybe we remove it and try again. Get a new one. Game state. The function is not showing up. Maybe that's what we have to do. I don't know. So it has to be like game state. Do I have to do like this and then do it? No, it's just not doing anything. So static public start game. Yeah, let's see this. Attach a transform to the button, and from the onPress action, you can select functions you created on the scripts that the transform carries. For example, transform A is a script that contains the function story object containing the code. Drag this transform in the button slot and select the name of the script. Then from the list, select your function. Okay. Why is the script named start game? That's not what I want. This button is not doing what I want it to do. My script was linked to the canvas. Instead of adding the script to the button, I added the canvas instead, and then I could access the script and the public function. Oh, so if I add the game state to the canvas, then here we add one and we say, wait, what did he do? Instead of adding the script to the button, I added it to the canvas, and then I could access the script in the public function. Okay. So the canvas has the script. Please tell me it doesn't execute start game like immediately. Okay, it doesn't. Okay, so then here, we start now. I just want the canvas. So I can just pull canvas here. Call canvas. Hey, there's our game object. Canvas. Oh, game state. Start game. We try now. Missing game state does start game. That's interesting. Okay, bring the canvas over as our object. Okay, and okay, so game state has to be part of canvas, or else it just doesn't. Or we have a script just for this. Okay, maybe that's what we do, because I don't really want to assign my script on here. So we're going to create a new script and just say like UI script, and we're going to open this up, and we're just going to say that it has a function, and it just has a static, or just public void start game, and what that does is just calls game state dot start game. And then wait, what? Why is this not showing? There we go. So we have our UI. We pull the UI onto canvas, and we come here and we call UI start game. Now we do it and we say, boom! Oh, okay, cool. So that actually really isn't that bad. So what we want to do is start game should hide all of our components. So this is going to be our components. So we're going to do Unity get child game objects. Get list of child game objects. For each transform, child in transform, child is your child transform. Cool. Okay, so that's exactly basically what we need right there. So what we're going to say is, why didn't that copy? Just not, is this not selected properly? Whatever. Okay. So for each transform child in transform, we're going to say transform.scale.y equals 0. So when we start game, they should all just like go. Just scale. What does it have? Transform dot. Game object. That doesn't look right. Unity, change scale of game of object in script. Scale object is via script. Local scale. Okay. Okay. So we try now. And we say, I didn't do anything. It didn't do anything. So that's not good. Unity hide game object. Is there a renderer attached to this? That's like render dot game object dot. Huh. Interesting. So let's just go like all out. Just say game object. So I'm using obsolete. What is obsolete here? Renderer is obsolete. Well, I'm not using that now. So game object, which is going to be the, oh wait, can we just do get component? Oh no, game object dot find, and we'll say welcome text. Yeah, let's say welcome text dot local transform dot local scale new vector 3000. I mean, this does not seem ideal, but that does it. What do you use instead of renderer? Hide, unhide game object. Cool. Oh, set active false. Oh, that's way better. Let's change these to not do that, because that's just dirty. So we're going to turn off the other ones. So game object, what is it? Is it lose and win? Lose, lost and won. Lost text and one text are going to be active false. So this one's false. We have lost, we have won, and then we have our button. So we have lost, won, and then we have start game button. Why is it? Sometimes when I let up, it's just like start game button. And then, okay, so if we start game, oh. Okay, we'll just change these to welcome. Rename you lost. Rename you won. Rename start game. All right. So we're just going to say welcome. You lost. You won. And start game. And this one should also be you lost and you won. Build that built. Now let's try. These should disappear. They did, okay. Start game, cool. That seems to be working. So what we can do now is we can check the updates and say, okay, let's say, what are we at here? We're at an hour and 27 minutes. I think we might be able to get this hour and a half. Let's see. Okay, so we care about the game state. So if game state dot is game over, dot is game over, then we're going to say we want the start game to come back, because this is always going to come up, right? So this is true. And if game state dot did win game, did win game, then we'll say that we want the U1 to show. Else, we want to say you lost. Plain and simple, straightforward. Now we had to figure out if you won or lost. So let me see here. Let's see Unity on collision. On collision enter for each contact point. I want to see what the collision thing is. Destroy game object. I don't want this to explode. New. Not quite. Okay, collision has the game object. Okay, so we can go back. We can look at this. This was on collision enter. So we will use this. So we are going to have a ball. Yeah, no, the ball can do this. The ball can totally do this. So void on collision enter, I believe, is this. And we say on collision enter, collision, collision. Okay, cool. And collision, collision. What we're going to say is if collision dot game object dot name equals so we're going to give these more meaningful names. So we're going to say rename left wall, and this is going to be right wall, and this is going to be rename AI wall, and this is going to be renamed to player wall. Cool. So we can come over here and we can say, hey, if this is the AI wall, then what we say is game object dot end game state dot end game, and we won. Else if collision dot game object dot name equals player wall, then we say that game state dot end game false. Make sure this builds. Oh. Make sure this builds. An object reference is required for the non-static field. That should be a static. So start game. Why would we ever reset? Nothing's calling reset. I don't think we need that. And we should be good to build. So it is game over. And good. So let's see how our game does. We're going to start our game. And let's lose. That didn't do anything. Also, the start game button didn't go away now. What did we do? Null reference. Object reference not set to an instance of an object. Well, that sounds good. Well, let's rename this start the game because that should be different, I guess. Start the game. Okay. This was working, so I don't know what happened, but the button is still there. Okay. Object reference not set to an instance of an object. Where is this at? UI.cs line 17. Do I need to do like canvas dot? Unity find nested game object. Okay, so let's just do canvas / you lost. Or actually, we'll change this to rename UI canvas. There, we'll be explicit. See if that works. Let's try building. Works fine. Try again. Okay. So line 16 and 17 is failing. Game object dot find. Maybe we do this afterwards. That should be perfectly fine. Okay. $15 and $14. Oh, is this saying... Okay, so maybe if we make the entire canvas not active, maybe we just say game object dot set active false. And then when we update, if is all right, let's say this. If not, is it get active game object dot get that active? That active self? And we say game object dot set active true. And then we had to decide what we're doing here. So U less U1 is true or false. So you can't set it to active if it is active. Okay, how about this? Void set geo active. Game object child, and we say if child dot active self child dot set active false. There we go. Actually, what we'll take will be a string child, so name, and then we say game object child equals game object dot find name. Okay, cool. So let's remove this because this is not what we need here. Actually, it is what we need. If we are not active, then we activate ourselves. Now, what we do is we disable the things that we don't need. So what we're going to say is okay, if active self and not active, then we say that. Else if not child dot active self and active. So if it's not active and we want it to activate, then we say child dot set active true. Let's do this. We'll just be explicit. Huh. There we go. So what we're saying here is activate ourself. So we're turning off the you lost the you won. So now if we when we start the game, everything is fine. So on an update, if we're not active, but we should be because the game is over, then what we're going to do is we're going to turn off the welcome screen. So set child active welcome. Actually, we'll say UI canvas / welcome false, because we do not want this one to be active, right? And what we'll do is we'll say we're setting U1 to true. Oh no, start the game to true. Start the game true. And then when we do this, we're going to say U1 is, if we won, then we're going to set it to active. So the U1 is active and U lost is not active. And then we will do a similar thing here, except if you lost, then we flip the switch and this is false and this is true. Now, if we're lucky, this will build. It built. If we're lucky, this will not stop. This will work. So we run it. We start the game. We say start. Everything's fine. We'll let this lose. And okay, so it didn't lose yet. It should have lost. So what is going on here? So, is there a throw 1, 2, 3? System.exception 2, 3. Can we do that? Oh my god. Okay, hold on. Unity log output. Debug.log. Okay, so we'll just do this. Debug.log poke. Okay, cool. Everything looks fine. Start the game. Where would I see the log? Where's our console? Unity console. Window console. Window console. And we'll put that up here. It's not logging anything. Okay. All right, so by default, one thing I want to change is I want these to, like, by default be turned off. So that's good enough for now. So let's just try again, just make sure that it's not doing something weird. And it is. Okay, cool. So on collision enter is not working. On collision enter. Why is this not copying? Okay, cool. So I simply can't paste in here. What the fuck? Mono develop Unity can't paste. Oh. Sometimes I get this problem. Okay, cool. Well, we're not going to do that right now. So it looks like it's actually spelled correctly what we're doing here, but instead, so the collision isn't happening. So Unity on collision enter not called. Are you using 2D collider and rigid bodies? I am using rigid bodies, but it's not 2D. Try this. On collision enter. Interesting. On collision enter for a collision. Debug.log poke. And he suggested what? Debug.log collision.gameObject.tag. Collision.gameObject.tag. Collision. Okay. We have the console. Yeah, it should be colliding. So I don't know what is going on, but it is failing. Well, we could do on a fixed update. Okay, well, we have another option here, which is we could do a fixed update. Yeah, let's do this. Let's do this. So that didn't work too well, but we can do a fixed update. And we can say if transform.position. So, well, the only problem is this. If we do it this way, we need to know about the other ones, but we'll do it. So game object player equals game object dot find, and we named that what? The player paddle? Well, no, it's not really. We actually don't need it. Because what we can just say, if position dot, we're moving in the Z, I think it is, right? Z, no, we're moving in the X. So position dot X. So for the player is at X -9. So if it's less than equal to 9.5, equal to, well, let's give it a bit of, yeah, well, whatever. Then we game state dot end game false. I'm going to say else if transform dot position dot x greater than equal to, oh wait, -9. Sorry, it's less than equal -9. Oh wait, yeah, we say -9. and then greater than equal to 9. Wait, this should just be this. Game state dot end game true, and we just say screw on collision enter and make sure this builds fine, and now try. Okay, cool. The game ended. So we'll do this instead and say if game is over, we'll instead say nothing's blowing up. So game state that is game over. Is this correct? Is game over, game over. Okay, so end game, game over equals true. Okay, so here, if game state that is game over, debug.log foo. Well, let's see. So did that log? That didn't log. Okay, now we have a different problem. Log game state dot is game over. False, false. Oh. Set active true doesn't seem to be doing anything. Okay, so maybe set active is not what I want. So Unity hide UI elements. Okay, yeah, they're just setting scale. So fuck. We were trying to be all. So okay, so active. So if not active. How's this doing that? Okay. Okay, cool. We're just going to change this and just say else. So set visible, and we're going to say the visibility. So if not active, child dot transform dot scale local scale was new vector 3 0 0 0. Otherwise, it equals local scale is new vector 3 equals 1 1. Fuck you 1. Okay, cool. So when we start game, we're going to do okay. So set visible canvas UI canvas slash lost, false, and then you, what the hell, you won. And now we're coming up on the 2-hour mark, so we really need to wrap this up here. So let's hopefully get this wrapped up here. So game object.set active. And then, all right, so transform dot local scale equals new vector 3 1 1 1, and then set child active true or false. Does this work? Cool. Well, let's see if this runs. So now what we can actually do is come in here and say these start at scale, 0. No, welcome doesn't. Damn it. You lost starts at 0 and you won starts at 0. Save it and let's try and see if this works. Okay, and we start game. Shit's not going away, yo. Okay. So we can't change this thing itself. Okay, cool. Okay. Let's go back to how we had it here, okay? Okay, cool. And we have a second one. So this is we have welcome, and we have start game. Start the game. So instead, we show start the game true. Oh, we already doing that. See if that works. That appears to be working better. Congratulations, you. Okay, cool. So we need to make this bigger. So that's fine. That's fine. You won. We'll make the width 300. Now we have the wrong thing. If it's hitting our wall, we should lose. So if it's at, so this is the AI paddles at -9. I misread that. So we're going to swap this around. So we won true and we won false. And I think we actually maybe have done it. And we're almost right at the 2-hour mark. Come back to the scene. We can start. Start the game, please. And we start the game. You lost, try again. Okay, so we leave it right here, and we're just gonna come over here. You won! Boom! There is Pong in 3D with Unity. Almost exactly at the 2-hour mark. Had some debugging, had some weird things. We did move a little bit past what we did with the Python version. The Python version was just, you win and the game ends and it pops you back out of the game and it just tells you you won or you lost, right? So we did move past that. We do have a button for starting the game, right? But this is also 2 hours versus the 1 hour and 13 on that one. But if you consider that I am pretty familiar with that and not so familiar with this, maybe that balances out. Then again, we were also going a lot more into detail on that in terms of, how to do things. So, I think we're going to keep trying Unity a little bit. I don't. Tell me in the comments below if you're interested in me continuing it with Unity, or if there's other things you want to try. I'm considering also trying Unreal and Panda 3D, and possibly just going with raw OpenGL ourselves, which seems a little crazy to me, but I've done it before and it was pretty fun. Or using something like Ogre, which has Python bindings, and it's just a rendering engine, and we do all the game logic ourselves. So let me know what you think. I hope you enjoyed, and hopefully it's not another 3 years before the next one. You guys have a wonderful day. Thank you so much, and I will catch you next time.